Hello and welcome to GLISA's video tutorial introducing EPA's Stormwater Calculator tool. The EPA Stormwater Calculator compares site-specific green infrastructure projects to determine how best to reduce stormwater runoff from traveling from a property to local waterways where it could impact water quality. This video is meant to provide additional guidance for potential end users in the Great Lakes region and to help navigate and better understand EPA's Stormwater Calculator and its application. In this video, I'll first walk through the tool and highlight key features and outputs that will be helpful in assessing stormwater capture at your site and for making informed management decisions. Then I'll provide an example demonstration of how this tool can be applied. I'm going to transition now to opening the tool and briefly explain how to navigate its key functions. I'll do this by typing into my web browser, EPA Stormwater Calculator. I'll select the National Stormwater Calculator from usepa.gov site, which will take me to the EPA's Water Research page, home to the National Stormwater Calculator. This page provides a lot of great information that could help you learn more about this extensive tool beyond this tutorial. It includes comprehensive user guides, frequently asked questions, and more about stormwater management. For now, I'm going to access the tool by selecting this blue button, which says Access the National Stormwater Calculator, and the tool will take a short moment to load. The first thing we'll see is an option to enter a site name before getting started and a short video introducing the tool. I'm going to select Get Started without entering a site name at this time. Here is the tool. By default, it centers on a map of the United States, which is where the data in this tool is available. Let me first highlight the key features in this tool before walking through an example demonstration. To the left is a sidebar with various icons. I'll select this arrow, which will expand the tabs here. First, we have a Locations tab, which is the first tab displayed when you open the tool. You can enter a site address, use this polygon tool to draw your area of interest, or add the number of acres you'd like to assess, not exceeding 12 acres. Each tab here will include a directions box, which I encourage you to review your first time using the tool. Next is the Soil tab, which retrieves soil data from a national database and informs runoff potential. You are provided a legend identifying the corresponding soil type displayed on the map by color to help make your selection. Soil drainage provides estimates of how quickly runoff infiltrates the area based on soil type, or a user can enter the inches per hour value if you're aware of a more accurate number at your site. Topography choices are listed to inform steepness of the area, which impacts infiltration of runoff. Users make selections based on the corresponding color. Precipitation and temperature provides nearest rain gauges and weather stations to your site, as well as an option to download historical precipitation and temperature data. Depending on location, the nearest sites may not be within view on the map, but zooming out will help find one. Climate change data is where you can select future scenarios such as hot, dry, or warm and wet, extreme storm scenarios, and apply near or far term scenarios. This tab offers a lot of additional resources and chart data which you can download. Land cover allows you to describe your site's land cover and visualizes the area with a satellite view to assist with your classification. Low impact design, or LID controls. This is used when testing potential green infrastructure in stormwater management techniques. Project cost. This is where you can enter project type, site suitability, and cost region, which helps populate an estimated cost for your specific project. You can click on these options to learn more about what each means. And a results section. This is where your site's stormwater data are computed based on your selections, and statistics are provided such as average annual rainfall and runoff, rainfall retention, cost summary, and more. We'll examine these tabs more during our example demonstration. A few more items in the tool I want to review are in the upper right corner. You can create a new project or save your current project at any time. When saving a project, you'll be asked to enter your email address and send an XML file to save locally. Then, you can upload that file later using the Open button. A list of resources are also available if you're running into problems using the tool or need help understanding one of the selection options. And a button to contact the Stormwater Calculator team is available for additional help if you may need it. Now I'm going to move into a more detailed overview of the tool using a hypothetical example. The best way to use this tool is to first conduct an initial assessment of the site as a baseline scenario, followed by one or more exploratory scenarios testing different site selections. Moving to the Location tab, I'll enter my city of interest, which is Lagoon Beach, a residential area near Bay City, Michigan. You can either hit the Enter button or you can click the magnifying glass to zoom to that location. I want to see the landscape more clearly, so I'm going to change my view to aerial. I'm also going to use the polygon tool to set my land area that I want to assess. To close the polygon, I need to make sure to double-click the closing pin. Now I'll go through the tabs and simulate my baseline scenario. Soil type data is available at this location and is shaded yellow, so I'll select sand, which is low runoff. Soil drainage is blue at this site, so I can gather that 1 inch or greater is infiltrated per hour. I'm going to keep the estimated drainage provided, which is site-specific. Topography is yellow, meaning it is flat, so I'm going to make the selection indicating a 2% slope. Moving on to the weather stations and rain gauges selection, the closest station is the MBS International Airport, highlighted in yellow. So I'll keep this as is. The other stations are much further away, so I'll leave those be. Moving on to the Climate tab, since I'm starting by exploring my baseline, I'm going to focus on historical data and select No Change. Next is land cover. Considering my area of interest, this is mainly lawn and impervious surfaces. I'm considering rooftops, driveways, and roads for my impervious surfaces, so I'll update the lawn percentage and my impervious percentage will automatically update. For now, I'm going to skip the LID controls and cost estimate for my baseline, but we'll revisit both of these later. Now, on the Results tab for my baseline assessment, I need to set my years to analyze. This is the number of most recent years of rainfall records to use. And Event Threshold, the minimum amount of daily rainfall or runoff that will constitute a measurable event. I'm going to keep both of these as is and select Refresh Results. This can take a moment, especially if you're adding more years to analyze. Now that this has loaded, I'm going to use this button to set my baseline scenario. So in our summary results, we see 2 pie charts and a statistics table with current and baseline scenarios. Since we only have one scenario so far, the data is the same, but as we go back and enter new scenario information, this current scenario data will update. Our baseline is showing an annual rainfall in inches and inches of runoff. For the next scenario, we're going to take into account climate changes and add LID controls to the area to see what difference these can make. But otherwise, everything else will stay the same. First, I'm going back to the Climate tab. I'm going to select a scenario with more storms and warm, wet seasons in the near term and assess my plans based on this. Next is adding LID controls. I can learn about each of these stormwater capture strategies by selecting them and set my controls even more precisely. I'll show this for my LID of choice at this site, which is permeable pavement. I want to see the impact of upgrading driveways to permeable pavement on my block. I'm going to set this to 20% of the area being covered by permeable pavement, and I'll also add a 2-inch storm for sizing. Next, I'll update the Project Cost tab. This is a redevelopment project, and the site suitability is moderate. Again, I can click each option to learn more about these selections. My cost region is Detroit, and the regional multiplier is 1.04, and I'll keep these as suggested. Okay, so here we go back to the results. I get a notice that site data has changed, and results will need to be refreshed. I'm going to keep my analysis years and event threshold the same, and I'll select Refresh Results. This can take some time to load. What we can observe now is that our current scenario is different from our baseline inches of annual rainfall, which corresponds with the heavier rainfall events. I can point out too that at the bottom we are retaining more rainfall in inches compared to our baseline. And wrapping up, I'll point out that below we have more reporting options to explore, including your site description, cost summary, and more. Once you've finished your analysis, you can print your results to a PDF file, which will provide you with each of these reporting options for your site. There are countless assessments you can make of your site as is, and this is a useful tool for making comparisons for future greening projects. This will conclude our demonstration for how to use the Stormwater Calculator, and I hope that this was a helpful walkthrough. This video was created by GLISA, a climate adaptation partnership team funded by the National Oceanic and Atmospheric Administration, dedicated to helping the Great Lakes region build lasting and equitable climate resilience. Under a project funded by Michigan Sea Grant, this is one of several tutorial videos intended to help make climate, weather, and coastal resilience tools more accessible to end users in the Great Lakes region. There are also accompanying guidance documents available for each of the tools covered in these tutorial videos, available at the link in this video description. The guidance document contains contact information if you have any questions about the tool. This video and accompanying guidance document were created for educational purposes only and are in no way affiliated with EPA's Stormwater Calculator or its developers.